Okay, then yeah, today is a long session about Kubernetes and Kubernetes secrets, in the sense of the Kubernetes secrets resource. Because sometimes people say, you're going to show me some secrets about Kubernetes, and it's not secrets about Kubernetes, it's Kubernetes secrets, the resource object, that you see that, well, at least for me, the first time that I started working with Kubernetes secrets, first of all, I thought that there were secrets because they are named secrets. But probably some of you, or if not, we're going to see today, yeah, secrets are not secret by default in Kubernetes. So you might start populating your secrets across a Kubernetes cluster. And if your cluster is easily compromised, there are many reasons that a Kubernetes cluster might be compromised, then this attacker will just get all your secrets without much problem. And well, today we're going to see some examples of how to deal with all the secrets. I'm using Minikube. Also, I'm using OpenShift, but in any case, everything that I'm going to show you is Kubernetes vanilla, which means that it's, let's say, it's the standard way, but each of the Kubernetes implementation has its own way to do things as well. So you can just go to the low-level approach. That's what we're going to see today using Minikube. But also, depending on your Kubernetes platform, might be easier or harder. For example, we'll see an example here with Minikube that we are going to encrypt secrets. And you'll see that you need to restart the Kube API server, we need to configure YAML files, and well, we need to do a lot of things. And in case of OpenShift, it's just a toggle button. So you push that button, and all these steps happens automatically. But it's something specific to OpenShift, and the same probably happens with the Google implementation, Azure implementation, and so on. Okay, so let's start. My name is Alex Soto. My Twitter is Alex Soto B. My email is asotoway@redhat.com. If you've got any question, you can interrupt me during the session. And also, if you want, you can also ask me tomorrow or whatever in Twitter or also in email. It's not a problem to send me an email. I work in Red Hat, and I am the co-author of Testing Java Microservices, Quarkus Cookbook, and Securing Kubernetes Secrets, which in this book, it's like this deep dive, but more things. So I basically, in this talk, I've just taken some chapters, let's say, of the book and just show you. So let's start about what is a secret. And I just checked the Cambridge Dictionary and said that a secret is a piece of information that is only known by one person or a few people and should not be told to others. And yeah, probably here we could start discussing about funny things about secrets, right? When we put the secret on a paper, or there are like, everyone knows the password of the production database, things like that. Probably most of us has lived something like that. But in theory, a secret is something that just one person should know. Because, if it's known by more people, then you are increasing the chance of that secret be shared. But before we start with Kubernetes secrets, I really like listening music. And in the music, as in the secrets, there can be a soft secrets and hard secrets. Secrets that are really easy to be known and decrypted, and others that are harder. But at the very end, a secret can always be compromised. There is no silver bullet. But let me show you, this is what I like to call it a soft secret in songs, that is when there are a backmasked message in the song, right? This is really easy to detect because you're listening to music, and at some time you listen something weird, something that is like, what they are saying? And then you see that it seems that they're saying something, but it's not a understandable word, and then you just need to play it on the reverse side, and you will hear what they're saying. And there are many songs that are using this approach. I'm just putting here Rain of the Beatles, Loser of Beck, Almost Perfect Sense of Roger Waters, and Empty Spaces of Pink Floyd. If you listen any of these songs, you'll see that in some point of the song there is some weird words. But of course, you can also make, let's say, or put a secret in a song that it's not detectable at all. And let me introduce you the V minor key. V minor key is a way to write music. We've got several examples. You'll see here, for example, the Rite of the Valkyrias of Wagner, Symphony No. 8, or in the Hall of the Mountain of Per Jean. All these songs are written in V minor. And maybe you said, and what is the secret here? Well, the secret is that V minor key is used when we want to express in the music a fatality, death, that your life is in danger. You see the Valkyrias. You know Valkyrias is that, let's say it's in the Nordic mythology, that they were in the field of war when all the heroes are dead, and they just take the best ones and put it to Valhalla, so it's dead. Symphony No. 8, it's used, for example, in Smurfs, and when Gargamel is trying to take the Smurfs, it always sounds this song because the life of the Smurfs are in danger. Or, for example, in the Hall of the Mountain King, it's when the trolls are trying to take Per Jean. So you might say, okay, and what is the secret here? And the secret is here. The Show Must Go On song was released in October 14 in 1991, and Freddie Mercury died on the 24th of November of 1991. And you know in which key was written The Show Must Go On? In V minor. If we knew that, we just know that this song was talking about a fatality that was coming. So before we know that Freddie Mercury was dying, the song just tells us that thing, thanks of this V minor knowledge. So as you can see, this song has a secret, but it was really a good protected secret. So let's go to the more technical secrets, but just let me tell you that there is no silver bullet in secrets, in encryption, nothing. I like to say that it's like an onion. You need to just create one layer, and then another layer, and another layer. So if one of those layers are compromised, you still have some more layers out there to protect the secret. But at the very end, things might go wrong. Before we start with what is Kubernetes Secrets, I like to show you some quick introduction of Kubernetes, because it's important to understand how it works. Basically, we've got master or primary nodes. This is where all the, let's say, engine of Kubernetes lives. You see that there is the Kube API server. There is an etcd. At the end, etcd is like a database. There is a scheduler, which is the one who tries to find a node and schedule their or workloads or pods. And then there is the controllers that just go there and just validate that all the infrastructure is working as expected. Usually the developers and the operations communicate with the primary node. And then we've got the worker nodes that contains a kubelet, and at the very end, this is where the containers lives. Okay, so this worker nodes has a container runtime interface, and when the primary node finds a node and said, okay, this node is the one that I want to run my container, it just boot up that container in that node using the container runtime interface. Then it's boot up, and of course, it injects some data inside. And of all this schema, what is really important is the etcd part. At least it's important for us to understand how the secret works. Etcd runs on master node by default. So when we install Kubernetes, there is in the primary node or in the master node, we've got there a etcd. But nothing blocks you to install etcd in another node or in another machine. And see that this might be one good way to deal with etcd, because if you put etcd in the master in the master nodes, what you're getting in these cases is that if your master node is compromised, your etcd server is also compromised. If you don't know what is etcd, it's just a distributed key value database, and what it's stored there is the state of the cluster. And this is something really interesting, because sometimes when we do a kubectl get pods and we get the list of the pods, we can think that it's just going to the worker nodes, listing all the pods and getting all the pods, but it's not in that way. Basically, when we do a kubectl get pods, it goes to the etcd, it queries etcd to get all the pods from a given namespace and returns the information. So this is where everything is stored. And one of the things that are stored there are the secrets. When we do a Kubernetes secret, we'll see now, these secrets are stored in etcd. And you see that if etcd is compromised, your secrets are compromised as well. If you do backups of your etcd, then if you have a problem with your backups, for example, they are lost somewhere, then someone can also access to your secrets. Or if you expose your logs or your etcd logs, also the secret is exposed. So you see that etcd, in terms of secrets, is an important piece. So what is a Kubernetes secret? At the end, a Kubernetes secret is a Kubernetes object, like, for example, a pod, a deployment, a config map, that contains a small amount of sensitive data. And this secret can be injected as a volume or as an environment variable. So when you create a pod, you say, OK, I want to use a secret. And this secret can be put inside the pod as an environment variable. So you put a name of an environment variable, and then you inject, or you put the name of the Kubernetes secret and the value is injected, or as a volume. And as a volume, it means that when you start the pod, that secret is mapped into a file and stored into a file directory or the file system of the pod. And that's also important, because notice that if your pod is compromised, so anyone or some attackers get access to that pod, for example, that's a kubectl exec and get access to the pod, then it's just a matter of checking the environment variables and see the secret, or inject, or just getting the file system, getting the files where are the secrets, and get the value. So let's just start with a quick demo about this, so you at least now we can understand exactly how secrets works. Okay. I've got several clusters now. Let me see. Okay, QNS default. Okay, now there is nothing here, and I want to create a secret. How I create a secret? Okay, you can do kubectl create secret, and then you set it there or your secret using the CLI tooling. We'll do it later. But in this case, I'm going to use probably the way that most of us interact with Kubernetes, which is with the YAML file or a JSON file. In this case, it's a YAML file. I've got here a secret. See that it's a very simple secret where I've got that it's of type or kind secret. You give it a name. You can also put the namespace where you want to store this secret, and here is the data. And the data is your secret content. And in this case, I'm setting a key greeting.message with a value. And this value, one of the important things is that it should be encoded in base 64. So it's not encrypted, it's just hashed. It's just a base 64. I can just go to this file and decode it, and you'll see here the message. I think that I can do this, doing something like this. No. No, I cannot remember. Was -d? Well, if not, okay, I'm not very worried. I always use this website. Okay, I put it here and do a decode, and it says hello. You see that? The message is really not encrypted. It's just there as a plain text. So what's happened if I do kubectl apply -f of this secret? Okay, you don't, no worries. You don't. Okay, I think that it's working. Yeah. Now I can do kubectl get secrets. And yeah, I've got a lot of secrets, but the one that is important here is this greeting secret is this one, which is opaque. Now we've got a secret in my cluster, in my namespace, and I could inject it and do whatever I want. That's true. And you might say, now my secret is there, and it's protected against everyone. But if I do kubectl get secret, and I get it this secret, okay, you see exactly the same thing, and now it's the funny thing. If I do -o YAML, here is the data. And remember that this is a base 64 encoding, so if an attacker can get the secret, get access to the Kubernetes cluster and do kubectl get secrets and get this secret, you can do a -o YAML, get it, the data, go to the base, go to a decoder of base 64 and get it the secret. So you can see that, okay, yeah, secrets are not very secreted at all. Then, also, you might now face another problem, and it's, I've created a secret, but this secret is in a YAML file, and this YAML file contains here the code in base 64. So it means that if I lost this file, if I send this file to the wrong person, then this person will have also the secret. So let's see, first of all, how to fix this problem, the problem of having these YAML files with secrets there in base 64. So why this is important? Why it's important to start from the beginning, from the YAML file, protecting your secret? Because maybe some of you are starting with GitOps. And basically, GitOps and DevOps is the key to meet the insatiable demand for delivering quality applications rapidly. Basically, thanks to DevOps, we are able to deploy really quickly to production in an easy way, in an automatic way. And then what you need to take, first of all, is that DevOps, you might think that it's about dev and ops, right? So it's like, okay, it's something that it's about the development team and the operations team, but that's not true. A DevOps team is all the team. The operations, the PMO, the people from business, security, development, QA, and yeah, DBA. I'm not saying that DBAs are zombies. I'm saying that they love Walking Dead, okay? So, yeah, you need to have this. This is what is known shift left. So everyone should be involved from the beginning in your in the development of your product. Because then, if it's not in that way, if not everyone is involved since the beginning, we will have something like this. This is my release process where there's a lot of people pushing, trying to release your service, your application, and well, who is that guy? That is someone, maybe some of you might say, yeah, this is a DBA that is trying to, no, don't go to production. Just check that SQL scripts. Maybe it's the testers. No, we have not tested enough. Don't go to production. Also, what is this guy? Maybe it's the architect. The architect is surfing on this ball. And then there is this guy. Maybe it's the product owner. I don't know. But you see that releasing is quite complicated. And the problem is that it's not this, it's that it's happening more and more and more, because we are releasing to production maybe once every 3 months, which means that every 3 months we are getting these problems. So we need to find a way to be able to deploy to production easily and regularly. And this is what helps us, continuous integration and continuous delivery. Probably most of you already know continuous integration is this part where we build the project, we test the project, we do some security checks, and finally, we release the project. And in the context of continuous integration, releasing means that we need to take our container or jar file, WAR file, or our application and upload it to an artifact repository. This is the release process. And then, of course, we've got deploy to stage environment, deploying to production environment, which is the part of continuous delivery. So if we automate all these parts, then we will be able to release often. And what's about GitOps and all this process? What is GitOps and how this is related to that, what you explained you before about Kubernetes secrets? Well, GitOps just assumes that Git is the single source of truth. So everything goes to Git. So if it's not in Git, it's not taken into consideration. It means that it's not there. It's not in production. And all the operations goes through Git. So when we want to deploy my application, I need to deploy it through Git. If I want to create a secret, I need to put it in Git. If I want to manage my infrastructure, I manage it through Git. And this allows us to treat everything as code, and what is even more important is make all the operations go through Git, which means that I can do, for example, a pull request of my infrastructure. And if I want to change my infrastructure, for example, adding a new user or updating my database version, I do through a pull request that can be reviewed and ultimately merge. So GitOps is a developer-centric approach to continuous delivery and infrastructure operation. And it's GitOps because all of us knows Git, so why we need to learn a new tool. As I said, we can review changes beforehand. We can send a pull request. Someone can review it and can say, okay, it has sense to do it, or, oh, let's just check and if it's really what we want. And what is even more important is that we can audit the changes. Since it's in Git, we can add a comment. So if someone someday, after 3 months of some changes, wonders why this change was in production, he just needs to go to Git, do a Git blame, check who made the change and why. So you can also use Git as an audit way to understand why your production environment is how it is. So you might say, okay, so we need to create a Kubernetes secret. This Kubernetes secret is created with a YAML. If we are adopting GitOps, this YAML goes into the Git repository, and the secret is in plain text, which means that everyone at any time could go to Git, download the YAML file, and see the secret. So how we can fix this problem? The problem is fixed with the project that is called Sealed Secrets. Maybe some of you already know that it works in this way. We've got a Kubernetes secret, the YAML file. At the end, someone knows the login and password because, for example, the DBA creates a login and password for accessing to the database. So this guy knows the login and password. So it's going to create a Kubernetes secret. And then it's going to run kubectl encrypts secret. And this process, what it does is just connects to Kubernetes cluster, gets a public key, and encrypts the secret. So after that time, the secret is encrypted. Then we can safely push that secret to Git because it's encrypted. If someone gets this YAML file, we'll see just a bunch of bytes. Then, what's happened when I want to apply this secret to the Kubernetes cluster? Okay, I just need to do the reverse side. Just decrypt the YAML file and apply that secret. And this decryption happens automatically by Kubernetes. Because remember that it was Kubernetes who provided us the public key, which means that it also has the private key to decrypt. Let me show you how this works. I'm going to change namespace to, I think the sealed, here in this namespace. I think that they have nothing. Well, it doesn't matter if I got something or not, but they just want to be sure that everything is clean. You do get secrets. Okay, there is no secret. I mean, yeah, there are secrets, but these are from. I think that I can delete it. But in any case, these are secrets for Tecton, so it doesn't matter. Now, the first thing that I need to do is a kubectl. I got here all the instructions, but since it's super long session, okay, I didn't try it here. No worries. So the first thing that I need to do is run kubectl. I've already installed. In fact, I can show you since we've got time. Kubectl. This is the project. Okay, it's from Binami Labs. It's called Seal Secrets, and it's just a Kubernetes controller. So you need to apply some YAML file to your Kubernetes cluster, and also you have the kubectl CLI for interacting. Now, when I do this kubectl fetch cert, what I'm doing is installing the certificate to encrypt data. And kubectl just connects to my Kubernetes cluster, asks for the public or for the certificate, just fetch it and store it locally. So after that time, kubectl can start encrypting secrets. And the only thing that I need to do is run this command that I'm going to explain you now in a few moments. Basically, I'm just saying, I want to encrypt something that is in YAML. Remember that with Kubernetes, it could be a YAML or a JSON. The file that I want to encrypt is named secrets.yaml, and the output, so the encrypted secret, is going to be stored in greeting secret sealed secrets.yaml. Then it's not named secret, yeah. Oh, kubectl. Yeah, it's YAML or yes, it's YAML. No such file directory. What's happening now? No such file or directory. Yeah, it's this one. Come on. kubectl minus format YAML. Yeah, then it says I'm expecting. Okay, let's do it in another way then. pb copy kubectl minus format YAML. I paste it. Come on. But okay. Yeah, then why it's not greeting secret, seal it, secret.yml. Okay, never mind. This is the secret. See that the type is sealed secret. Has the same name, greeting secret, but now you see the greeting message. It's encrypted. So now it's safe to store this YAML file into Git, because the secret is just encrypted. It's just a sealed secret that it's encrypted, and then I could do a Git commit safely. But now you might say, okay, but I want to apply this secret to the Kubernetes cluster, and in my Kubernetes cluster, I want that this sealed secret becomes a secret, because I'm not interested on this chunk of bytes. What I'm interested is in the secret itself. So now I can do kubectl apply -f, greeting sealed secret. See that the sealed secret is created. I can do kubectl get sealed secret. And you see here my sealed secret. But the funny thing is that if I do kubectl get secret, you see here that 18 seconds ago, a new secret was created. This secret is a Kubernetes secret, it's not a Kubernetes sealed secret. And if I do kubectl get secret -o YAML, you can see that the secret, it comes from a sealed secret. You can see it somewhere here with the owner reference. This is the way that we can make the mapping between a sealed secret and a secret. But what is important here is that the greeting.data, it's encrypted. So thanks of sealed secrets, I'm able to encrypt my YAML files, push it to Git, and when I do the kubectl apply, this encrypted YAML file is sent to the Kubernetes cluster, and then Kubernetes cluster will decrypt the data and create a Kubernetes secret without encrypting that data. And why it's important this owner reference is here? Because what's happening if I want to delete this secret? Now I can just do kubectl delete -f, not secret, the greeting sealed secret. Remember that this file is this one, the sealed one. I can delete it, and I can do kubectl get sealed secret, and there is no secret. And even I can do kubectl get secret, and you see that now the secret is not here anymore. And this is thanks of this owner reference. So when you create a sealed secret, there's a tight life cycle between the sealed secret and the secret itself. So if you delete the sealed secret, also you're deleting the secret. Is there any question? Yeah?
Sorry, I might have spaced you in the first part, but where are you storing the encryption key in the cluster?
Yeah. So Where is the question is about where is the encryption key and in which part you install it. Yeah, this is done. Look, when I do here in the installation, in this part, you can use Helm or or YAML file. But when you install sealed secrets, let's say, wait, here, let me see here, controller. You can do it. Well, in fact, I can just show you. Yeah, we can do it. You can go here, sealed secrets, releases. No, this is not Helm. Here. Here. When I apply this YAML file, this controller.yml, so before the session I've done kubectl apply -f of controller.yml. This installs the kubectl inside the Kubernetes cluster, so the control is there, and create this pair of public and private keys. So it's automatically created. As far as I know, you cannot change a lot. I mean, it's something. It's an automatic process. It's explained in the documentation exactly. They are using. Yeah, it's explained it. Wait, because it's here. It's here. It explains. It explains. I cannot find it now, but it explains exactly which keys are using and which algorithms are using. But keep in mind that you can also what you can configure is the secret rotation. So you can rotate that keys. You can re-encrypt the sealed secrets as well. So you can change from one private key to another private key because you want to rotate it, maybe because it has been compromised. And then you run a command and everything is updated automatically. But let's say that QSeal abstracts you from all these key and certificates management, or at least the low levels. Okay. I'm just checking because I remember that there is a place where they are here. Yeah, you're using the, you see here, generates a, it says, the controller looks for a cluster-wide private public key pair on a startup and generates a new, so it generates a new, this 4096 bits RSA key pair. It's asymmetric encryption, obviously. And well, this is the public key portion is the one that it's sent to encrypt. This is when we do the QSeal fetch cert. This is where all these things happen. Yeah, it's a really well documented project, and we have been using for a long time, and it works well. It also integrates with Helm as well. So yeah, it and customized. So there are other solutions. For example, there is also a solution for Ansible. So if you are using Ansible, also there is the Ansible Crypt. And also there is a plugin called Helm Encryption, which is a plugin for Helm, but it just works for encrypting the Helm resources. This QSeal, the great way it has is that you just install it in your cluster, and then with QSeal you just encrypts everything. Okay, now, yeah. Okay, now we've seen that we can encrypt the YAML files. It worked. We push it. Then we did the kubectl apply of that secret, and it was decrypted in the cluster and created. And let's say that when I've done the kubectl get secret -o YAML, we could see the content there and encrypted. But let me start a Minikube now. And let me start this one. Yeah. Minikube, start Vault. Now, we're going to create also a secret. I mean, we're going to assume that we have already done the seal secret, and we apply it, and the secret was in the there in the cluster. Now I'm just starting this Vault example. You can just go also here. I'm just opening more things. Yeah, I've already done this. I'm just checking that I'm not missing. I'm not leaving anything. Yeah, here there's more things. Okay, let me see if this starts. Okay, now I've got my Minikube cluster. I'm going to do kubectl get pods. There is nothing. And I'm going to deploy a secret. this secret, it's here. It's this one. For example, we could use, I think that secret file. It could be a good one. Again, you see that there is just a secret, a Kubernetes secret, that it has a name, it has a username, and it has a password. And what I want you to notice here is that this username and password is just base64. Also, I've got here another secret, which is exactly the same, but I like to show it because you can also use this structure in secrets. Probably if you already know config maps, it sounds you familiar, where you say instead of putting data and the key and the value in base64 and the key and the value in base64, you can just use string data. You put here a file, in this case application.properties, and then with this symbol you say that the following things are the content of this key, and see that the username and password are not base64. It's done automatically. So if you create a secret with data, you need to provide the base64 encoding. If you create it with a string data, then it's a string, and you are not required to put it in base64. Okay, there are things that I never understand why it is in this way, but it is what it is. Then let me do kubectl apply -f of the first secret file. Okay, now I've got here my secret, which is the db secret file. And let me show you this example. You see that this is just a deployment file that I'm deploying my application, and in this case, I'm just injecting the secret as an environment variable. Remember that I've created a secret that's named db secret, and in the way that it's done is just in the spec you set the container. The container is this one, which is Fedora 33. Okay, I mean it's just an image, and the secret is injected from an environment variable that's going to be named username. The secret is db secret, and the key that we want to inject is one that is named username. Let me apply it, and then I show you again this kubectl apply -f. Okay, now here is the map. The map has a username key with a value. This is the base64 in a secret named db secret file. Then if we go here, okay, it's not the same secret. Kubectl, it doesn't matter because probably it's here. dbsec. I can just deploy greeting, and the secret is named db secret file. Okay, now yes. Now it's creating this container, and it's injecting as a secret. As you can see. Wait, let me show you again. Yes, OEML. So we've got here the secret. The data is here. Where is data? Hello. Here. Username and password. Notice that there is a key named username. And to reference this username as an environment variable in my pod, I just done this. Okay, I just went to the secret key ref section. I said that this is the name of the secret. This is the key that I want to inject, and the value needs to be injected in this environment variable. Now, okay, now what's happening if I do kubectl exec -ti of this pod? Suppose that I am an attacker and I'm able to get access to the pod. I can just go here and do export. And we check here that the username variable is there, and it sets the value unencrypted. So it's like, okay, I just get it access to the pod, I do an export, and I got the secret. Or maybe it's not accessing the pod, but has access to the logs. And sometimes the logs print the environment variables. So, okay, your Kubernetes cluster is super protected, but your logging system is not, or the backup of your logging system is not protected. And then the secret is there. Of course, you might say, yeah, but I will never put a secret in as an environment variable. Sometimes you need to do it, especially in the legacy applications. But you might say, okay, it doesn't matter because I know that I can put it in a volume. Let me delete this example now. And let me show you as a volume. So you might say, yeah, but instead of setting as an environment variable, I'm going to mount a volume and put inside that volume the secret. Because, you know, at the end, an attacker will never know where I have stored that file. This is something that you might say. And in this case, what I'm here is creating a volume mount with name dbsec mount path /etc/dbsec. So this is the path that I think that an attacker will never know. I say that it's read-only true. And then here in the volume, you define this secret, this volume. You said this volume mount comes from a volume called dbsec. And I've defined it here. The volume is dbsec. And the secret that I want to use for that volume is named dbsecret file. Now I applied this. It was this one. Now it's running. I can do kubectl exec -ti /bin/bash. I can do an export, and yeah, now there is no username, which is good. Also, I could do, since I know where it is, I can go to cat etc. etc. It's called, I don't remember now. etc. What is the definition? Secret? Not. I've done this export and now everything has a screw. Here. Okay, this is not a volume. It was. Okay, I'm going to do it. It was etc dbsec, exactly. Yeah. kubectl exec etc dbsec. And here there is my keys. Remember that my secret has two keys, username and password. One key is username, the other one is password. So it creates automatically a file named username. And if I do a cat of username, you see here dbuser. Again, not encrypted. And you can go do a cat password, and you here see the password. So, okay, now it's not an environment variable, it's a file. And you might say, okay, yeah, I don't have. You might say, okay, that's fine. I've got here a file, but the attacker will never know where this file is. But let me see, because I don't know if the 1 second, because I think that the command was changed in Fedora, and I've got somewhere here. What is the command? It's here. Yeah, because they changed that thing. It was fstab or ftap. Well, in any case, because now I cannot remember what was the. 1 second. If I check it, okay. If not, doesn't matter because it's not important. But basically, there is a command in Linux that lets you check all the volumes. So you just need to do go here and say, okay, I just list all the volumes. I get it /etc/dbsec. I go there, I find the files, I get the passwords. It's true that it's better than an environment variable because at the end it's just not as easy as doing an export. You need to check the volumes and get the values. Also, it's better because usually the files contents are not locked. Environment variables might be done, but not the files. So you're also protecting your log system from exposing a secret. So if you need to choose between environment variable and volume, choose volume. It's not super safe because you've seen that the things are stored there unencrypted, but it's better than an environment variable. But let me go a bit more and let me show you how a secret is stored inside etcd, because remember that it's etcd who stores the secret. So now let me copy, I can do this. I need to change one thing. Okay, now suppose that I'm an attacker and I get access to your etcd database. Remember that at the end it's a database, that it's there and anyone can access. Also, you might say, yeah, but it's protected. That's true, but it's not protected by default. So you need to protect it. That's the first thing. And the second thing is that there is a tool or a web page, an internet that you just connects there, and it gives you all. I mean, it just scans worldwide all the etcds that are not protected and exposes the IPs. So it's just a weird database, weird web page that I don't know if it's totally legal, but it's just a scanning internet, and every time that finds an etcd that is unprotected, it's just published there. And there are some papers that say that around 70% of the etcds are not protected. So, okay, it seems that it might be easy, or you have a big chance of having an etcd not protected at all. Now, I've got here the etcd. This is where all the secrets are stored. And I'm going to, yeah, I need to do this. Okay, let me take, to access to etcd, in this case, in Minikube, it's protected with the certificates, and I need to get this certificate. Set microservices-p vault. And I'm going to get this certificate. I just access. Let me go here. And just in case you're wondering where are these secrets are stored. Let me check one moment. Okay. These secrets are stored in var, lib, search, etcd. So any attacker that gets access to your nodes, it also might have these certificates to log into your etcd. We can go here, so you can see that I'm not lying you, and I do a cat of var. It was var lib minikube. Well, yeah, in this case it's minikube because it's minikube. Search etcd. And here we have the peer key. This is the private key, so it's there. Anyone who has access to your node has access to that key. I can even copy. I copy the and I put it, for example, here. And of course, also I need the public key to log. And I'm going again here, and now I do a cat of peer.crt. Here is my certificate that I can also copy. I copy here. Okay, now I've got both of the certificates here in demos. Now I could just exit and exit. I'm going to demos. This is where I've got the peer certificate and the peer key. And I apply or I configure etcd CTL. What? No. Okay. I think that if I've done in this way, it's going to work as well. One by one. So now I just configure etcd CTL. etcd CTL is a tool for accessing an etcd cluster. And finally, I just go here, and I can query my etcd database that is inside my Kubernetes cluster. I think that was named in this way. And you see, this is how a secret is stored in etcd. And you see here, it's not encrypted even in etcd. So you are not just having your secrets.yml file not encrypted. You just do not have your secrets when are injected into the pod encrypted as an environment variable or as a file are not encrypted. And when they are stored in etcd, they are not encrypted. You see? So there are big changes, a lot of places that your secret is spread and is not protected. So you can use kubectl to protect, that's true, and you're protecting Git. But then when you are inside Kubernetes, there is the logs, there is the pods, there is the containers, there is etcd. A lot of places contains a secret not encrypted. And remember that we said that a secret is something that should be only known by one person. And you see here it is known by a lot of systems. So let's see how we could, or first way of protecting this. It's using encryption secrets at rest. I don't know if you know this. The first time that I read encryption secrets at rest, the first thing that comes to my mind is, oh, a REST API. But no, it's not a REST API. It means that there are two types of data. Data in motion and data at rest. In motion is when you are sending from one party to another party. Usually we are using HTTPS, so it's not a big problem. And the data at rest is when you store that data, because it seems that it's at rest. And in this case, Kubernetes supports encryption secrets at rest, which is, as I said, encrypting your secrets when they are stored. And basically it works in this way. We've got a master node, or a primary node. We apply a secret, and before it's stored to etcd, we configure this master node to encrypt it. Okay, so you just go there and said, okay, I want to encrypt my secret with this algorithm. You just configure that algorithm, and then it just works. Let's see this demo, which is a bit complicated because, as I said before, depending on your platform, it's easier. In case of OpenShift, it's just enable one toggle button. In case of Minikube, there is a lot of things to do, so I need to just check the instructions because you know you need to create a file. Well, you'll see now. But the important thing is that you'll notice that at the end, the encryption is, that the secret is encrypted. So let's go to Git. All this, I mean, that most of this content that I'm showing you now is available. I will share with you the GitHub repo. And in fact, it's just the chapter 4 of the book. So what we have seen now is chapter 3 and chapter 4. And both of the things are open and available. So yeah, you will get it this. Then we will see more things that are in other chapters that I think that we have no public repo for that. But well, yeah, you'll see. At the end, all the information is in internet, right? And in the book, the thing is that it's explained and it's all together, but everything at the end is out there. Also, if you're interested in the book, just send me an email and I can send you a discount code for like 50%, things like that, no problem. Okay, now, let me go again here. We need to go to Kubernetes. How we configure a primary node to encrypt data, it's by using a YAML file. The YAML file is this one. You see it's of kind encryption configuration. We want to encrypt secrets. And it's funny, because you can encrypt whatever you want. You can even encrypt a pot if you want. It's something really, this kind of thing that's it's curious in Kubernetes, right? Because they say that there are secrets, but secrets are not encrypted. But then, if you want to enable encryption, you can encrypt a secret or a config map. So yeah, it's always, when you start going deep to this kind of things, you get these surprises. And then you set a provider. This provider is how you want to encrypt data. I'm going to use this algorithm, and then you need to set the keys. And the keys are, so the encryption occurs in order. So if I have here like 3 keys, then it encrypts with the top key. So for example, with key 1. And when it decrypts, it just tries the first one. If it works, it's OK. If not, tries the second one. If it works, then it decrypts the content, OK? So it's a way that you've got to have several keys and updating that keys without losing the backward secrets. And then you set here a secret, that this is a base64 secret. And yes, it's a base64 secret. So, OK. Yeah, you might say that if I lose this YAML file, yeah, you get it exactly the same problem as before, that you are showing the way how to decrypt secrets. But, OK, let's apply this. And although it's a YAML file, you are not going to do a kubectl apply, because this is something that happens on the Kube API server. So what you need to do is take this file, copy inside your primary node, and restart kubeAPI server pointing out to that file. This is here. I think that, yeah, as I said before, there is a lot of instructions that it's at least for me, it's impossible to remember. So for the reason I've got all that files here. I think that it was where it is. Not here, sorry. It's another one. This one. Yeah. Here is the information that I need to take. This is the file that I want to create. I'm going to create two certs as well. So I'm going to do minikube SSH. So I'm just -p vault. So I'm just getting inside the primary node. I'm going to here. So this is where all my certs lives. And I'm going to take this file, encryption config. pbcopy .yaml. So I'm just taking this YAML file, and here I'm going to create it. Like we can name it, well, we're going to name it in the same way so we can follow. The name is encryptionconfig.yaml. Okay, then we go here and do a BI encryption config.yaml, and I paste it. Prefer to. Now, this is something that you should do in your Kubernetes, in all your Kubernetes primary nodes, creating this YAML file. Okay. Encryption. Yeah, sudo vi encryption.yaml, and I think that I need to do this. Encryption config. Now I've got the encryption config there created, and the last thing that I need to do is restart the kubeAPI server so this configuration gets or it's enabled. I'm going to do exit, and in this case, to go faster, and we're going to stop the minikube. So I'm going to do minikube stop here. Minikube stop -p vault. And now that it's stopped, I'm going to start it again. And what is important is to configure where this YAML file has been stored, because we need to set, or we need to configure kubeAPI server that when a secret is coming to the kubeAPI server, you need to go to this encryption configuration object, encrypt the secret, and then store it. And this is done here by, in case of, well, it's not in case of minikube. I mean that in all the Kubernetes implementations, you need to do it in this way. You need to go to the minikube and say there is a parameter that is called API server.encryptionprovider.config. This is a parameter that you set in the kubeAPI configuration files, and you need to set the location where this YAML file is. So now if I run it, and if I've done lib minikube search encryption config.yaml, encryption config.yaml, yeah, I think that everything is fine. Now I'm just restarting. In case of a production, you do not need to shut down all your cluster. What you can do is just restart the Kube API server, because you know that. Remember that we said that a primary node has a Kube API server. It has the scheduler, the controllers, the etcd. So you only need to restart the Kube API server and see that restarting the Kube API server means that there is no downtime. Because when someone is trying to access to your system, it's doing, or I mean that a client, it's doing through the worker nodes, not through the master nodes. Which means that you can restart the Kube API server. It's true that you will not be able to deploy anything, but there will be no downtime. Okay, now let's wait. See here how it detected that now there is a new configuration. Okay, let's wait. Is there any question while this is booting up? Okay. So yeah, basically what we need to understand here is that by default, okay, what's happened? Kube API server, starting failed content Kube API server. Clash loop back off. Okay. Great. Stop at the end. Okay. Vault has the file. Yeah. Barley minikube search. Encryption config. Yeah, this is the file. Yes. It's exactly the same. So for any reason, error syncing bot. Okay. Let's try again. Yeah, but it's a QFSH. If it's not work, you see here the Kube scheduler, the control manager. Oops. If it's not working, no worries, because at the very end, this is container D, this is the container runtime. In any case, if it's not working, it doesn't matter, because this is not the best solution, and I will explain you now why. Let's see if it seems that it's going to fail for the same. There's no logs here. Restarting failed Kube API server. Yeah, it seems that there is some problem, but why? It's named Vault. In theory, oh. Let me check if the file it's there. Minikube SSH USB Vault /bart minikube no bar lib minikube search encryption. Maybe it has not been stored there, the file. Okay, that's the problem, but why? Why it has not been stored there? It's Let me. Encryption config.yaml. Maybe that is the thing. Now, cat cd bar lib minikube search. Why it's not copied and it's not failing? PHP server, front proxy. It's curious. So I can do whatever I want. No, now I do not have permissions. And if I do sudo, sudo, yeah, I can do that. But in any case, because it's in the, okay, man. Oh, okay, because I copied in the wrong directory. Okay, copy /root to encryption config to /bar lib minikube search. Now I do this, and now it is. Okay, now finally. Let's see now. Now, okay, finally. Okay, now, I can do Kubernetes Secret. And you see that there is that secret that we created. That was this db secret get file. I can do kubectl get secret -o -o YAML secret -o YAML, and yeah, you see here that it's still the same way, because this secret was one secret that we created before. So it has not been encrypted. Things are encrypted after we apply the configuration. So if we have some secret and then we apply the configuration, we need to re-encrypt all the secrets. There is some scripts out there that you just run them and they just encrypt everything. But for now, let's do a kubectl delete secret, this secret, db secret file. And let's apply, again, kubectl, apply, -f, secret file. Now I've applied it. If I do kubectl get secret, you see that the data is still the same. Yeah, it's still the same. And it should be the same. In theory, not. But why? Oh, man. Yeah, it works. It's larming. It's this file. I'm not going to spend more time on this because now I will explain you why this way is not correct. So I don't want to you get bored. But now I'm just curious. Yes, that's the file. The file is here. It has a key. Source. But it's stored in this format. And in theory, there should be encrypted the secret. Let's see how it's inside the etcd. We go there. Remember that we can do kubectl port forward. And I think that we did here. cd demos etcd ctl. But see that now the secret is encrypted in etcd. You see that? You remember before that we said here you could see the password and not now. Secrets. Now remember that when you apply a secret, the secret itself is decoded when it's created. The reason for that is that when you deploy that secret to an application, that secret is injected, not encrypted. You see now in a moment that I can just decrypt. I can deploy the same example as before. You've got to apply -f. For example, yeah, I can do the deployment as a volume. Okay, let me delete it first. Save. Deploy everything Quarkus. You've got to apply -f. Deploy everything volume. Okay, now I'm just creating an application for a secret that in theory it's encrypted. But if I do kubectl get pods and it's this one, kubectl exec -ti, this /bin/bash, I can go to cat/etcd dbsec, username or password, and data is still there. It's not encrypted. And you might say, yes, it's normal, because remember that I said that the encryption configuration occurs when we want to store to etcd. So when we are storing to etcd, the secret is encrypted, but when you are injected into the application, the secret is encrypted and put it on the pod. For this reason, when I did a kubectl get secret -oyaml, it was acting as a application and just put it there unencrypted. Again, if I do this etcd ctl, you see that in etcd they are really encrypted. You see that this is the key and all the content is encrypted. So you might say, okay, we are just step by step protecting our secrets. First, we are using seal secrets to protect on Git. Then we are using this encryption configuration file for encrypted secrets when they are stored in etcd. So you say, okay, now I have not to worry about etcd. Of course, I know that when I inject it in my application, I might have some problems. And some of you might say, okay, let's fix another problem. And the problem itself is that, as you might see here, is that the encryption configuration is a YAML file. You've seen that I was storing in my primary node, in my master node. And the etcd is also running in my primary node. So suppose that there is an attacker, get access to my primary node, just goes to etcd, do etcd get, see that everything is encrypted. And you might say, oh, they know how to protect the secrets. But if you see here, it's saying which key is using. So it might say, but I've got access to the primary node, so what I'm going to do is just searching for a YAML file that contains, this string. And when I found this string, I've got the key, because remember that the key is, it's plain. It was here. It was just here. So I just get it, this key. I've got the key. I've got the etcd data. I'm just going to decrypt, and I've got the secret. So you see that, yeah, it seems a good idea at the beginning, right? But when you start thinking about what it really is, you see that there is some problems. Also, I know that, that we've got some customers that they say, yes, I know, but if someone gets access to my primary node, I will have bigger problems than knowing if they are getting this key or not. At the end, it depends on your culture about security. If you want to update your security or in other levels or not, or if this level is OK for you. Now, let's do a break of 20 minutes for the coffee. It's 10:30. And then I will explain you how to fix this problem and also how to fix the problem of having the secrets injected as a volume, as an environment variables in plain text in your pods. So see you in 20 minutes or so. Yeah, thank you. Remember that we said that, OK, encryption configuration was OK, but you've got the key and the etcd in the same machine. So if the machine is compromised, you get the key, you get the values, you can decrypt the values, and done. But, yeah. First, it was created this encryption config, and after some time, Kubernetes decided that it could be a good idea to create a KMS plugin, a key management system plugin. And it works in this way. Now, I've got a secret. This is a simplification. Okay, the process is quite complex because it's using double encryption and so on, but doesn't matter for now. You've got a secret. You do a kubectl apply of this secret. The secret goes to the primary node. And now, instead of using the encryption config object, what it does is just connects to an external system, to an external key management system that encrypts that data, usually using HTTPS, and then it gets back the result, and then the secret is stored in etcd. So it's exactly the same way as before. So we are just encrypting the content inside etcd. But the big difference is that now we've got two parties on the scene. First of all, the etcd. Second one, the KMS. And the KMS is deployed outside your primary node. So probably you're just starting a virtual machine. You put it there, Vault. In this case, it's Vault, because it's an example, but it could be any other key management system. You put it there, your key management system, in a virtual machine, and then you've got other virtual machines that belongs to the Kubernetes cluster. So if your primary node is compromised, OK, attacker will go there to the etcd, will get the values which are encrypted, will start finding that key in your primary node, and they will find nothing. What's happening if your key management system is compromised? OK, the attacker will get the key, but that's all. You just have the key. It has no data. Probably you will detect it, and then you will revoke that keys and re-encrypt everything. Of course, as I said all the time, there is no silver bullet solution, because an attacker could compromise the KMS machine, it could compromise the primary machines, then get it the key, get the values, and decrypt it. That's true. But of course, it's harder to compromise two systems than one system. And let me show you this example. I've got here running minikube start -p secrets vault. Now what I'm starting here is a Kubernetes cluster. And in this time, the Kubernetes cluster has a KMS system installed outside of the Kubernetes cluster, because at the very end, Minikube is in my case, it's a virtual machine. So I've got inside the virtual machine one part, which is the Kubernetes, and another part, which is the KMS. Of course, in your case, you will have two virtual machines. In this case, for demo purposes, it's just the same. And the way we've got to configure the KMS is using this file. Again, it's a file that you need to store to your primary node. See that you say that there is a provider. This provider is type KMS. It's not AAS CVC. So you are not putting the algorithm. You're just saying, OK, this is the provider, which is KMS. You put it a name. It doesn't matter. It's just a name. In this case, I'm using Vault, Hashicorp Vault, which is a key management system. We'll see in a few moments more how Vault can help us in terms of security. And then, of course, you need to set this. And this is basically an endpoint or a socket endpoint where the KMS is running. So it's the URL. And this communication happens through HTTPS. So it's true that you're communicating with an external system, but this external system is secured by HTTPS. So now I've got here. OK, now I can do Minikube SSH again. -p secrets vault. And if I do PS-F, you'll see somewhere over here. Well, I can do grep vault. You see where it is. This is the kubelet. This is etcd. What is Vault running? PS? No, it's PS-F. OK, in theory, yeah. Well, we'll see now. But yeah, Vault is running. Or hope so. Yeah. At least it was running yesterday. OK, if not, we're going to install it. It's not a big deal. Now, assuming that this is working, I'm going to do kubectl port forward again. Put here secrets vault. So I'm just getting access to the etcd. I'm going to create a secret. In this case, OK, I'm going just to create a secret. Well, yes, it's created because I created it yesterday, but see that I've created just a secret with this name, with this username, the user, password, the password. This is what I said before, that we can create a secret using a YAML file or a JSON file, or using kubectl create secret, and you create the secret. I can do kubectl get secrets. OK, now I've seen this error. Well, now I'm starting getting scared of what's happening now. This is, I've got the keys. I think that the keys are here. OK, I don't know. I don't remember where we store the secrets. Well, OK. Yeah, no. Well, it's the same. DB, L, the secret, its name, this. Okay, now what I'm getting is that, yeah, that this is not the keys. I'm going to create them because I stored it yesterday somewhere, but I don't remember where. So we're going to do exactly the same. Secret. Cat / bar minikube leap minikube etcd leap minikube. It's not. Now, this is the encryption key that I showed you before. So in theory, it should be okay. And the last thing is getting the, oh, not this. Let me go here. ZTCD. Yeah, done correctly, right? Bar, leap. Where the... I'm checking if I can see where I where I store the keys. Okay. Here. Where are the keys? Yes, insert. Or they have been moved? Moved? I don't think so. Let's see. It's got TCD minikube search. Okay. So that this is a directory now, finally. Cat pure.crt. So I'm just copy this certificate. I want to remove pure.crt. Yeah, pure.crt. So now, yeah, it's a bit of cumbersome tasks, but I need to get the certificates, and it just every time that you start a cluster, you get a new certificate and a new key for etcd. So yeah, go to the key. And now Oh, and now give exit, give Carol port forward. Give Carol port forward. And now you see that the key is encrypted in the ATCD, but see that the value now it's KMS and name it Vault. So we are just saying to an attacker that no worries, don't spend time on looking here because you're not going to find anything because it's managed by KMS. So you see that we've got at the beginning we've got the keys and the secrets in the same node, and now we've got the keys in one node and the data in another node. It's separated, so if both systems are compromised, then yeah, we are stuck. But if not, if you're just, using Kubernetes, everything is encrypted in two systems. Let me go again to the slides. But again, now we are storing correctly secrets inside ATCD. They are encrypted, they are separated, the keys and the data. But when we create a pod, the data is there. And it's in plain or in clear text. So any attacker can get access to the pod and get that data. So the solution to avoid this is using vaults. And when I say vaults in this deep dive, we are going to talk about Hashicorp Vault because it's a vendor agnostic. It's just, key management system that can be installed on-prem or into any Kubernetes cluster. But if you are into cloud wall, for example, with Amazon, you know that Amazon have Amazon Secret Manager. Then you've got, that Azure has Azure Key Vaults. All these key management systems are also valid. Okay. Of course, you're getting some kind of vendor locking, but they are valid. And in the book, we explain how to do more or less the same thing like I'm going to show you today, but instead of using Hashicorp Vault, using these other key management systems. So basically, what we need to do is deploy our KMS system in a node, in this case Hashicorp Vault, and store all the secrets inside this key management system. And then when we want to get some secret, instead of injecting as a volume or injecting as an environment variable, what we can do is just communicate with HTTPS to that system, do a query, get the secret, and just use it. What is the big advantage of this approach? Is that your secret value is not a disk anymore, it's not as an environment variable, it's in memory. And of course, any attacker could dump your memory and just searching for the secret. But you may say that it's unlikely that he will find in which memory position is the secret. And in any case, if he's able to do it, if you apply some kind of rules for rotating secrets, when the attacker knows where is the secret, probably you've already rotated that secret. And as I said, we're going to talk today about Hashicorp Vault. Hashicorp Vault is it's a secret manager. As I said, Azure has its own, Amazon, GCP, all of them has its own, but Hashicorp Vault is agnostic in this sense, so it can be used in virtual machines, in Kubernetes. You can move from one cloud to another cloud, and it's still valid. It's a secret engine that you can store, for example, keys and values, as we've seen as a Kubernetes secrets. But also, it provides you a way to implement a two-factor authentication system. So it's really nice. If you are always wondering Probably you've got the Google Authenticator application that you've got this number that is changing every 30 seconds, and then you've got a QR code, and you just insert this into your Google Authentication, and then you authenticate with a password and with this number. Then this is also implemented with Hashicorp Vault. So of course you can rely on the Google Authentication servers, but in case of Vault, it implements you. So you can just ask Vault to generate a login and password and also this two-factor authentication, and it automatically provides you a QR code. So you've got a QR code, you scan it with your phone, with Google Authentication application, then you get this number, and then when you want to authenticate to your system, you need to set the username, the password, and the number that is there. Then you send this to Vault, and Vault notifies you if it's valid or not. In my case, that I was always wondering how these things work and how it's implemented. It's a super cool demo to do. And also, one of the nice things that has Vault is that can provide you all the PKI or all the certificates and private keys infrastructure for your application. So even, for example, SSH. So you can configure Vault to provide keys to your machines, and, for example, rotating that keys, and so on. And you do not need to manage manually all the creation of the keys, or the consuming the keys, or rotation the keys. It's done automatically by Vault. But, Vault also has one thing that it's called dynamic secrets. I don't know if, as far as I know, I think that Amazon, Azure, and Google secrets managers has not that concept. That is a secret that is dynamic. And keep in mind one thing. If there is no secret, it means that there's nothing to protect. And maybe that's the best way to work. If we as developers, if we as operators, we have no clue about the password. So who has the password? Because the password is still. The password is in the Vault, and it's automatically generated by Vault. So it's never shared with anyone. You just configure Vault to say, I want to connect to this database, and I want you to rotate the password every 10 minutes. And that's all. I do not specify any user, any password, nothing. Then Vault automatically is renewing that password maybe every 10 minutes. So it means that every 10 minutes it's going to connect to your Postgre SQL. We're going to see the example with Postgre, but it's any other database. It's going to connect there and update the password. And it's going to connect to your application and say, I update it to this password. So all this process happens automatically. Nobody knows exactly what is the password. Even the password is renewed every 5 minutes, and you don't need to do anything. It's just an automatic process. So if there is no password, you do not need to do any Kubernetes Secret YAML file, because the password doesn't exist. It's dynamic, and it's generated every time. Nobody knows the password, so there is no administrator that knows the password that maybe he write down in a paper and then share the paper or send an email to someone saying, hey, this is the password. No, because the password is not there. And the password is only, let's say, shared between the database and the application. And all this communication happens using HTTPS. So in theory, everything is secure. Also, you might say, okay, that's super cool. If I do not have a password, no password can be compromised. But I need to log to Vault to say, hey, I am application, and it's safe that you send me the password. Because you can always say, hey, I'm an application, send me the password. And you are not application, you're an attacker. And then you get the password. So you need to auto-authenticate against Vault. And Vault has a lot of different methods. One is user-based methods. User-based methods are username and password, tokens, for example. These are some elements that are use-based. Most of you might say, oh, I like user-based because, it's login password, and then I connect to Vault, and I get it, the database password, automatically generated. But we've got a password. That it's the Vault one. So we changed the Postgre or the database password for another password, which is the Vault. And we need to manage this password, even with the Kubernetes secrets, even with encrypting them and so on. And you might say, okay, with dynamic secrets, it was a good dream, but after all, there is a secret. It seems like there is a chicken egg problem. In fact, it's not, because also Vault has other authentication mechanisms like machine-based. Machine-based mechanisms are authentication methods that are specific to authenticate machines. So it's not a username and password. It's something that machines can deal easily. For example, the MAC address. This is something that we cannot remember, right? But you can say, okay, just keep in mind that there will be a service that is running in this MAC machine, or in this machine that has this MAC address, and with this username, and it's going to log and get it, the information that you provide. And you might say, okay, but what's happened if some attacker goes to that node, gets the MAC, and tries to authenticate? That works, but then what it has, Vault, is another system that lets you define how many times a secret can be accessed. So in this case, you could say, I want you to log using this MAC address, but you can only log one time. So you know that if you log the first time, your application is trying to log there, and it's the first time it will log and revoke any other logging that occurs after that. So if an attacker gets access to your machine and tries, it will get not authentication error. And you might say, and what's happened if the attacker gets access to the node or to my machine before I deployed the application? Remember that I said that the password can only be accessed one time? The attacker will get access to that vault, that's true. But what will happen when you deploy your application? That your application will try to log, and you will get a not authentication error. Then if you are monitoring your application, you'll see that someone has access to your system, and then you can seal Vault. And that's pretty cool. It works really well. I used in all time ago, maybe like 6 or 7 years ago. Maybe 5 years ago. No, more. 7 years ago, where there was no Kubernetes. Everything was virtual machines, and it worked really well. But then it came Kubernetes, and you know that with Kubernetes you can scale up and scale down. So if you're not, it's unlikely that you can use any of these techniques. And Vault created a Kubernetes-based authentication method that I will explain you in a few moments, which is quite complicated to understand, but allows your services that are running in Kubernetes authenticate with Vault automatically without any password. And the last thing that Vault does really well is the audit management. You can define a lot of rules to detect any unwanted access to Vault. For example, you can define things like, my secrets are going to be accessed only from 8 a.m. to 9 p.m. And anything that happens out of this time, just raise an alert. So then, you know that from 8 a.m. to 9 p.m., 9 a.m., any access is perfectly fine. Your application will be able to get secrets from there. But after that point, any access will raise an alert. This is just an example of things that you can do, but it's really a powerful auditing system to detect any unwanted access. So as I said before, this is how the Kubernetes authentication method works. So any pod can access to Vault without having to know any username or any password. Because at the very end, as I said, the target is to have no passwords. If we do not have to manage any password, it means that we do not have to worry a lot about anything. This is my application. Sorry. This is Vault. Yeah, of course, Vault can be replicated. We can have several instances of Vault. And then we've got here a service account. Service account is the account that is running your application. Usually you define it in when you're deploying the application. Just say, yeah, this application runs in this service account name. And even you can create this service account in the same YAML or not. Then, what happens? The first thing is that when you boot up your application, the authentication method with Vault, so you, of course, you just need the Vault library on your application. In case of Java, there is a Vault API or jar file for Vault. The examples that I'm going to show you is using Quarkus, which Quarkus has a really good integration with Vault. But then it's just a matter, if you're Go, then it's just a matter of looking for how you integrate the Vault Go library into your system. But in any case, the first thing that you need to do to authenticate to Vault is using the service account GWT token. So when you create a service account with Kubernetes, you get a token, okay, a JWT token, and you also need to provide a role. So there are two pieces: a role that you need to configure in your application, but notice that it's a role. It's not a password. It's not a username. It's a role. It's compromised. It doesn't matter. And there is a JWT token, which is the service account JWT token, that again you create it, but you don't know exactly what it is because you just did a kubectl apply of that service account. Then in Vault, you have configured Vault to get access to the Kubernetes API server. And since someone has sent you the service account token and the role, you're going to make a query to the Kubernetes API server. And notice that to get access to this Kubernetes API server, you need to configure Vault to be able to get this request. So you're protecting at that time Vault against Kubernetes API. So you only can get the tokens from a service account. So you do not have access to all the Kubernetes API server, just a small part that gets service accounts. Then, well, basically, Vault will get this request to Kubernetes API server, will verify if the JWT token that you have sent from the application, because remember that this JWT token is in the pod or in the container, it's sent automatically, then it's verified. If it's verified and it said, okay, I know that this token is a valid token because it has been provided by Kubernetes API server, then it returns, and it says, "Okay, it works. It works okay." And since I provided the role, I know then that this user has, or this application has, a specific role. When it has this role, so it says, "My application, it's verified. It's a true Kubernetes application. It's a valid token." Then, with the role, I retrieve the policies. So I retry what this user can do. For example, if it has access to these secrets or not. Because at the end, what you want to do is get a secret. And to know if you can get that secret, you need to do it with a map in your policies. Then, if you don't have the policy of getting this secret, then you will get an error. But if your application is configured correctly, it's a correct role, and it's getting the secret assigned to that role, the token is returned, saying, okay, this is a token that it's a Vault token that you can use to retrieve secrets, to request and retrieve secrets. And this token can expire at every, every 15 minutes. So every 15 minutes, this process will be repeated. You will send the service account, get it the Kubernetes API, validate that it's a valid token, and then get back. And this is really useful because if you detect any threat on your application or on your service, you can always revoke that GWT token, and the next time that someone tries to access to the vault, it will get a not authenticated error. I know that it's quite complicated, but I would say that it's easy to configure, complicated to understand. But yeah, we'll see now. Okay, now we're going to start with demos. Now this demo, in this case, it's here, but I need the password, which is, I don't know where, here. Don't worry, I'm going to destroy the cluster after the session, so that's fine. Let me log. Well, in this case, I'm just using in OpenShift. Yeah, it's a login. And well, at the end, it's Kubernetes, just to show a bit of everything. Come on. Basically, to deploy a Vault in Kubernetes, you can use Helm, or you can also, yeah, I would say that most of the time I use Helm, but there is also a Vault operator. So if you're a fan of operators, and then you can just use an operator, and it works. Okay, display token. That's the token to log. Export cube. Doesn't matter. Okay, log. Kubernetes, it's, I don't remember, it's Vault, I guess. I think that it's Vault. Vault, yes. Kubectl get pods. You see that I've got one Vault instance, this one. Maybe if you are a Kubernetes, you've been playing with Kubernetes for a long time, you see that this is not a deployment, this is a stateful set. You see it for the name, right? You know that the stateful set allows you to get a pod with a known name. See that it says Vault -0. If I scale up Vault to 1 instance, 2 instance, 3 instance, it's going to name Vault 0, Vault 1, Vault 2, Vault 3. So you always know exactly the name of your pods. And then it has here the Vault Agent Injector. I will explain you why this is here. Basically, Vault Agent Injector is used when you have a legacy code that has no access to Vault. Suppose that you've got a, I don't know, Spring Boot application. You know that the Spring Boot application has also support for Vault, but suppose that you've got a Spring Boot application, really old Spring Boot application, and there is no Vault libraries, and you do not want to develop more this application because it's a legacy, but you want to use Vault for storing secrets. So can I use Vault without having to change my code? And the answer is yes, using the Vault Agent Injector. I want to show you how, but of course, my advice is that you adapt your code to Vault system. But if you have no time, or maybe you don't want to spend money on that application, there is the Vault Agent Injector. Okay, now we've got here Vault. I'm going to do kubectl exec -ti vault 0/bin/bash hash. And now here I've got Vault. I can do Vault. You see here that says all the I think that I can close this. All the things I can do. So I can do a Vault audit, Vault out, Vault KV for interacting with key value storage, monitor, etc. And the first thing that I'm going to do is Vault Secrets List. This just returns the list of secrets that are mounted, because you need to mount secrets with Vault. You see that there is one that is called sys, where all the system things are stored. Then there is one that is of type KV, which is key value. So you're storing secrets in a key value form. And it's in the path secret. This means that when I want to refer to the secrets stored to this part, I need to provide this name, secret. Then I got the one for identity, which is where you store all the things related to identities. Then I got this cubbyhole, which is where you remember that said that when you want to define secrets that can be accessed, for example, 1 time, 2 times, 3 times, this is how it's done. And here I've got another one of key value, which is named agents. So I've got some big places where I can store secrets in the form of key values. One is named agents, another one is called secret. For example, if I want to, let's say, enable, so I want to create one place to store my secrets, I will do it in this way: vault, secrets, enable, minus path, agents, minus version, blah, blah, blah. In this case, it would say that there is already agents here. You see it in this place. Then, how I can add some secrets, because at the end, I need to add some secrets. You can do it using Vault operator. That's one way. But in my cases, most of the time, I created these secrets using Vault CLI. See that I said Vault KV, because it's a key value. I want to put it in the path agents. Remember that this one. /Alex. So you see that in Vault, everything has a tree structure. So I'm just going to agents /Alex. This is the information regarding Alex. And the key name is Alex, and the key email, the value is this one. So if I run this, you see that I created a new secret inside agents with, let's say, with a name, Alex, and then all these properties. And what I want you to notice here, this. You see that this says version 2. This is happening because I've already done this call yesterday night. I didn't remove it. And now when I put it a new secret in this agents /Alex, since there was one, it creates a revision. It means that I can always have the historically of how my secret has been evolved or been modified, updated. There is a creation time, and in this case, there is a deletion time. So I can just put a secret and say, this secret should be removed this date. And then that date, the secret is removed. Notice that this is not a dynamic secret. We're going to see it later, the dynamic secret. Okay, but for now, just keep in mind that we are creating a secret, because not all the secrets can be dynamic. For example, your API key to access to Twitter API, for example, is something that you cannot rotate. It is what it is. So you need to store it in some way, and you store it in this here. Then, okay, I've got here the information, and even I could do a get. I can do get. And if I do a get, you see that there is a key, this creation time, destroyed version, and in data, you see all the information regarding Alex. Email and name. Of course, if I go here and change to another one, for example, Ada, you will say that there is no value in Ada. If we are interested, you could go here. I could change this to this, this, and this. And now I've got two secrets. One is in agents /Ada, another one is in agents Alex. I can do Vault get KV. I don't know if KV gets everything. No. But if I go, agents. Okay. I cannot read the yellow, not listing operation, the root. Okay. Agent/ADA. Then I get the information related to ADA. Okay. So now I've stored some secrets inside Vault. That's fine. Now Vault is encrypting all this data. So inside Vault, all this information is encrypted. It's not logged. It's perfectly stored. So you do not need Kubernetes secrets anymore. Because why you need a Kubernetes secret if the secret is here and you can store it correctly, encrypted, without having to deal with KMS, nor having to take care of the encryption configuration error, YAML file, sorry, nothing. I just have Vault. I put my secrets there and they are secured there. Now I want to get this secrets. And to do that, we've got two options. The first one is by using the Injector Agent. Remember that I said that with an Injector Agent is used when you've got a legacy code that you cannot touch, you cannot change to use Vault. And the second way is when you've got your project and you're doing as starting as a greenfield project, and you can get access from the Vault and inject it in memory. Let's start with the first one, which is this. Vault agent. This is an application that see that I have a service account named agents. I've got a service account named agents because remember that when I explained you the Kubernetes authentication model, I said that you need to provide the service account JOT token, right? The GWT token. And in this case, the service account is agents. And then I've got here some annotations, because remember that I said that my code is a legacy code that I don't want to change it. And what I do is that I want to be able that Hashicorp injects secrets, because we've got the agent running. The role is agents. Remember that I said you need to provide a JOT token and a role to authenticate to Vault. And this is the role. But you see that it's not a password. It doesn't matter if an attacker gets access to these agents. Then I need to set where are the elements that I want to access. In this case, in agents/config. Okay, maybe we need to change it. Yeah. Or create a one of config. I was create config here or not? No. Oh, well, we can create it. Well, we create it now. Then I'm saying that I want to create a config.properties file. And this config.properties file must contain all these secrets. And these secrets are done using this template. I know that the template is not really cool, but you see that it says, with the secret agents/config, get all the keys and all the values, and just print the key, value. And here you could put any other thing. You could put the equal symbol, I don't know, provide a YAML file or whatever your configuration file format it is. And then you see here that I'm just setting an image. It's a normal image. And you put image policy always, okay, name, and this is the service account. See that my application has nothing related to Hashicorp Vault inside. There is no Vault code. Now, let me do, let me create Let me create an agent slash config. Or well, it's easier to do. I'm going to change it here. Okay, so now what I want to do is inject the secrets that are in agents slash ADA as a config.properties file with the format that I specified in this template. kubectl apply -f kube vault agent. kubectl get pods. Okay, now it's running, and you see here that it says that it's 2 containers. I just defined one container, which was my code, my agents container. But it says 02 because I've got this Vault agent injector here. And basically what it does, this injector, is create a sidecar container to my application that will monitor my Vault and inject the secrets there. And you said, and okay, that's fine. This just happens at boot up time. And the truth is that, wait. And the truth is that it's not happening at boot time only. It only takes care of updating the values. So if, for example, you go to Vault, your secret is compromised, you can update the value, and automatically this agent will detect the change and populate it to your application. Because see that, since my application has no clue that there is a Vault or the secrets are in Vault, we need a helper, this sidecar container, which will make this work for us. Now what's happening with this? Why it's in it all the time? It's this workloads. Pending logs, no logs, events. Yeah. Okay. Come on. Wait. kubectl delete. Let me remove it, because since I changed it, it was okay, but what was failing probably is that couldn't find this secret. It was probably this was the problem. Now, you see that now both pods are running, okay? And if I do kubectl exec -ti /bin/bash, now you will see in a moment. Here I put it the config. Doesn't matter. Okay. Now you see that there are 2 containers. One is called agent, another one is called Vault agent. Now, and that's the funny thing, is that if I go to ATC, okay. 1 second, because now I cannot remember where isn't it TC? Vault? Yeah, Vault. You see secrets. Yeah, I was right. You see that there is a config.properties file here that appeared magically. There was not before. This is because I defined this in this YAML. You see that it's named config.properties. And if I do a cat of config.properties, you see that there is email colon and the mail name colon other. Okay, so it injects there the secrets automatically, and then you can read them from your application. And it's even more funny because I can do the next thing. kubectl get pods. I'm going to the vault. kubectl exec -ti /bin/ash vault. Well, let me wait. Let me go here. I think that's named Ada. So you see that now there is a new version that I changed the name from Ada to uppercase Ada. And you see that it's not changed yet. This is because Vault agent has a grace time. So it just says, okay, I've detected the change. I know that this should change, but I just wait some time so both of the values are valid. So let's wait for some seconds. It's still not yet. But after some time, you'll see that this file is automatically updated without restarting the pod. So if your application has some kind of watcher, file watcher, it can detect this change and populate that values to the application. Of course, some of you might say, okay, that's fine, but I'm still having the same problem that when I was injecting values as environment variables or files. And that's true. But remember that I said as well that this is a legacy application that I cannot use Vault. So this is the option or the workaround that Vault provides us. So we can use Vault for storing our secrets and use Kubernetes with our legacy applications. Let's see. Okay, come on. Well, we can wait a bit more, or we can leave the application running, I guess. Let's leave it running. kubectl get pods. You see that it's still here running. It has not been restarted. But some of you might say, yes, but I'm in a greenfield project and I want to use Vault to get access to secret and store in memory. So if it's in memory, then I do not need to do anything. And let me show you this file. This is the application. It's the same application, but now the only thing that I need to do is configure the role. Remember that you always have to provide the GWT token, but this is, you've seen that it's something transparent. I don't know, I just create a service account, and that's all. And then the Kubernetes library does the rest, and I need to provide a role, which is agents. If you remember, this is the same that we use here. But here, we set it as an annotation. Now, my application, which is here, since it's a Quarkus application and it's a new brand application, I only need to configure that I want to use this agent. Let me show you. The code. If you are interested, this is in Kubernetes Secret source agents. Okay, this is the agents application. Open Java agent resource. Maybe too big. you see here that I am injecting the key value secret engine. And let me just, here I'm saying, get the vault path. Well, it says that if config, then it's a 404. If not, read the secret and return the secret. You see that the secret is read and is never stored in any file, nor any environment variable. It's always, everything happens in memory. But, of course, I'm just using the Vault Quarkus integration. So let's deploy it. If Carol, well, with Carol exec. Let me see if the file has been updated or not. Okay, cat etc vault. Oh, cat etc vault. It was vault. Or I'm in the kufcarol. Yes. Was this one? Yeah. Kufcarol exec -ti /bin/bash. Agents, yeah, cat. See the vault. No, it was vault, right? Here, cat config. Now I. CD vault. Yes. CD etc. Vault. Kufcarol. Let me do it from here. That I don't know. Kufcarol exec. Well, in fact, well, yeah, doesn't matter. You see agents. CD etc vault. Okay, the directory has just disappeared. I don't know why. It's interesting. etc, yeah. Yeah, there is no vault, but yeah, this is the kind of things that I never understand why it's working the night before. Okay, wait. Yeah. Now. Because I put it etc. Okay, now and if I do a config, now you see that the name is with uppercase. Okay, so you see that I've not redeployed anything. And the file was auto-magically changed to the latest value. Okay, yeah, I've got kufcarol delete -f q vault agent. Now I'm going to do kufcarol apply -f of q auth. Now this is another agent. Remember that this version has no Vault agent installed. If I do kufcarol get pod, you see that it's only 1.1. And the reason, as I said, is because I'm using the Quarkus Vault extension that makes all these things for me. Again, see that there is no password, no login, if you will, for authenticating to Vault, because it's done automatically. Now, I can do kufcarol exec -ti of this /bash. Okay, now if there is no Vault, there is no directory, nothing, because now the secrets are directly consumed from Vault to the code. But I can do crawl localhost 8080. 8080 was agents /other. And you see here that I get the information. Okay, and in this case, the secret was never stored in disk nor an environment variable, always happens on memory. Now, before we end up, let me stop -p secret vault. And I'm going to show you a full example with Vault, a Quarkus application, a PostgreSQL, and dynamic secrets. And you'll see that the password of my database is never shown. Let me start -p. My list is this. Cube Pro start. Okay, now I start. I just have some mini cubes and I downloaded there all the images. Oh, I see that there is some translated in Spanish and other ones with English. Okay. Funny. Get pods. Now I've got here running service. It's a name generator. It just has a list of names. Then I've got here my PostgreSQL running. And I've got here my Vault running. I don't think that I've got anything else. No, okay. Here is the example I've deployed. Let me check get services because I don't remember where I leave it. Yeah. So I've got my Vault, my Postgres application, my name generator running. But I need to do some things before. And first of all, I need to configure Vault, and for this, I just create a Kubernetes job. If you see this Kubernetes job, it's quite big, where I'm basically saying that all this stuff, which I am configuring the dynamic secrets for Postgre. You see here I'm saying enable database because I want to enable dynamic secrets for database. And then I'm just configuring with all these super big query that my Postgre is in this host with this port. The database is DB. And here, this is the username and password that I want to change and I don't remember here, I want to remember default TTL 1 hour. So every hour, I'm going to change my PostgreSQL. Well, in fact, it's going to happen automatically. I'm not going to do anything at all. And then here, well, you need to configure. There is a lot of stuff that is in the book or even in the Vault web page. So I'm going to apply this secret. Of course, depending on how you administrate Vault, you will have a Kubernetes job. Maybe you just want to log as administrator of Vault. You want to log there and apply all these steps. Maybe you got the Vault UI and you do it using the Vault UI. Maybe you are using Vault operator and you use YAML files and you use a more a GitOps approach. In any case, you need to do all this configuration stuff. Then there is the Vault job. What I applied Vault secret, Vault job. Okay, that's the, or I show you. No, I show you. Oh, okay. Shit. I've done in the wrong way, I think. Gotta get secrets. No, I've done correctly. Okay. Oh. Okay, so I've got some secrets. The secret is the Vault login. This is how I can log into Vault, and this is a token. This is a specific token that I need for my application, because my application, the generator greeting application, requires a token that it's provided, that is this one, and also requires an access to a database, which is dynamic. Now I created the secret, and now, create here the secret, and now I'm going to configure Vault. kubectl apply -f Vault job. In this case, what I'm really doing now is configuring Vault with my token, configure the dynamic secrets, configure where is the database up and running, how many times I need to, how much, or the retention time for the secrets, and so on. Now let me check the job. Yeah, it's completed. So now my Vault application is configured. In fact, probably logs Vault 0. You can see here how everything happened. It says that the database has been enabled, that you initialized the database rotation queue, the row rotation queue, starting periodic ticker. So this is where you can see in the log lines that the database is being rotated automatically. Yeah.
Excuse me. The token is stored as a secret, but if somebody gets access to the token, can he access to Vault using the token?
No, this token is an application token. It's because we have not seen yet, but you see here, I've got another here. This application is a generator. The schema of this application is that I've got one service, or I've got two services. One service that just generates names randomly, and I've got another service that gets greeting messages. These greeting messages comes from a database. And to invoke that name service to get random names, you need a token, because you're protecting your service. Then this token is an application token that you need to provide to the application. And in this case, I'm storing as a key value in Vault, and I need to do it. I could do, I could just do a kubectl exec to the Vault instance and store that token, or I could just use Kubernetes secrets and use the job to create that token there. It's more like a management of Vault rather than, Now, I'm going to do kubectl apply -f of the application. And also I'm going to apply the same for the service. Kubectl for the service. Now, meanwhile, all this is deployed. I can show you here the example, which is welcome message. And what is important here in the welcome message is that there is no database password. I can go here to resources application.properties, and you see the important things here is here. This is the Postgre. I'm saying here that the Postgres is in Postgres, this port /db. And this is how I configure the data source. You see that I'm saying that this is a PostgreSQL, that the username is admin, but there is no password. The password is nowhere. Because as I said, the password is automatically generated and populated between Vault, the application, Vault, and Postgre. So me as a developer, I don't care about any password. Someone as an operator doesn't care about the password. There is no password. Yeah, I mean that, yes, there is password, but it's something that's automatically managed by Vault and the applications. Me as a human being, I don't care, I don't know exactly about the password. Now, if everything works as expected, yeah, now it's running. If I do kivcarl exec -ti of this, this /bin/bash ash, and then I do a curl to local host 8080 / and now you'll see, let me show you the code. The code is here. This is the welcome service. What I'm going is when I go to /welcome /message, I'm just getting the random message, and this random message comes from from the database, and then I'm getting using the name service. I'm generating the I'm generating the request to the name service with a BRR token. This BRR token is the one that I stored in Vault. So to authenticate from a welcome message from this service to the name service, I use a BRR token, and this BRR token is here injected directly from Vault. And notice that it's in memory. So by just using this annotation, I'm just getting the property from Vault and injecting in this variable. And yeah, basically that's all. Random messages, yeah. Okay, now, well, you see here, welcome, this is the entity. Okay, this is the entity of the database. This is the welcome message. Now, if I go to here and I do curl localhost 8080 /welcome /message, you say bonjour Ada. If I do another one, namaste Ada, bonjour Alexandra, hello Bor, hello, hola Kamesh, hola Edson, hola Alexandra. Okay, so you know, you're getting all these names. And what I want you to notice here, yeah, it's all of them. What I want you to notice here is that this application has no passwords. There is no password to authenticate against Vault because it's done by the Kubernetes auth method. There is no password to authenticate to Postgre because it's done by Vault. And the password is rotated automatically for me every hour. So every hour, the password will change and I will not need to do anything. For the reason I really like the approach of Vault and Dynamic Secrets and Quarkus, because it lets you forget about password. For this reason, I said that the best password is no password, because then you do not need to hide anything at all. And I think that's all the things. Yeah, that's the end. I put it just here, the details. Yeah, I mean, that is Twitter and email. Just ping me whatever you need. If you're interested in the book, also ping me. And I can find a discount of 40 or 50% for the book. The same for the other books. If you say, I mean, that's okay, the Securing Kubernetes Secrets, but I don't care. I prefer learning Quarkus. Yeah, in fact, the Quarkus cookbook, you can download it for free. If you go to developers.redhat.com and you register, you can download it for free. So, yeah, that's pretty much all. I think that, I know I've done a bit of an overview of the secrets in Kubernetes a bit. Maybe some of you know everything that I showed you. Maybe others said, yeah, but I like it, the Quarkus thing with this no password approach. Yeah, I hope that you found, at least you can leave from here with something new in your knowledge. So thank you very much.